गावडे सर मी जॉईन झालोय. गावडे सर गावडे सर
Yes, sir.
मी जॉईन झालो.
Okay, sir.
एकूण काही काही मोबाईलचा व्हिडिओ बंद करतो. चालू करताय का?
हाँ, okay, sir. We'll start now. Good morning, all of you. I am Professor Vishwajit Shinge from Mechanical Engineering Department from Nanasaheb Mahadik College of Engineering, Peth, Islampur. I welcome you all for 1 week faculty development program on advanced research methodology. This FDP is approved by AICTE and IST New Delhi from 26th July to 30th July 2021. This FDP is scheduled. Today, this is our first day for our FDP. I welcome all participants, our principal, Dr. A. Mirje sir, our today's resource person, Dr. Prakash Apate sir, and I request our principal, Dr. A. Mirje sir, to give introduction about our institute.
Thank you, Shinge sir. Good morning, and hoping all of you are safe at your place. On behalf of our young and dynamic secretary, Mr. Rahul Mahadik, our expert executive director, Professor Mahesh Joshi sir, I welcome the principal of this college, I welcome vice principal of this college, deans, HODs, faculties of mechanical and other departments, and participants from all colleges for this particular event. I especially welcome today's resource person, Professor P.R. Apate sir, who is a professor at College of Engineering, Pune. Let me introduce our college, that is Nanasaheb College of Engineering, which is located at Peth, which is started in the year 2011 under the visionary late Varasri Nanasaheb Mahadik sir to give technical knowledge to the poor needy students in this area to make their bright careers in engineering. We are running 5 different degree courses, namely mechanical, civil, electrical, electronics, and computer science. Initially, our college is affiliated to Shiva University, Kolhapur, and now it is affiliated to T.Batu University, Welding, which is the state university of the Maharashtra. 7 batches are already passed out from our college, and our alumni are serving in different companies in India as well as abroad. We have gone through the ISO certification. We are accredited by NAC Bangalore. Also, we are in the process of NBA as well. Our Svss has provided very good infrastructure with very good laboratories, workshop, library, gymkhana, etc. We have experienced and enthusiastic faculties in all departments. Our faculties are using online platforms like Zoom, Google Meet, Google Meeting, Teachmeet, etc. for teaching due to this pandemic situation. We are also using VLab in association with IIT Mumbai for online practicals for the student. We are implementing the concepts of project-based learning in which students are exposed to live projects and latest technologies from industrial experts. Some activities are done offline, some activities are done online for this period. Also, we have purchased the Gate Tutor software, which is used for conducting online examination, sending assignment to the student. College has also purchased so many other softwares like Great Learning for improving soft skills, professional skills, and aptitude of the students to the placement point of view. Okay, now let us come to our today's FDP. on advanced research methodology. Logically, the research is going on every field in the world now, whether it is medical field, commerce field, space, etc. But as an engineer, we have to concentrate on technical research because this technical research is directly related to technological development of our country. Technical research is nothing but some innovation or some discovery in terms of design of new product, new process, or new methods that will simplify our human life for day-to-day activity. I'm sure that this ability, I'm sure that this ability will be helpful to the faculties while teaching to the students as well as for individual development for research and PhD work to the faculty. We have selected all experienced doctorate resource persons who have gone through this research in the respective field, and I'm sure that they will guide you in detail in this ability. I wish all the best for this ability, which is arranged by mechanical department of this Nanasaheb College. I appeal to all participants that you should attend all these sessions regularly in time for detailed insights and take the benefit from this ability. Thank you and all the best for this ability. Thank you, sir. Over to you.
Thank you, sir.
Thank you, sir. Good morning, everyone, who are joined with us on this occasion of 1 week online faculty development program titled Advanced Research Methodology, which is jointly organized by Sri Venkateswara Shikshan Sanstha, Nanasaheb College of Engineering and Mechanical Engineering Department, in association with approval of IST New Delhi. We specially welcomes resource person for today's session, Dr. P.R. Apate, professor from College of Engineering Pune, who is giving his view on the subject defining research problem and world-class results. We warm welcome to Honorable Rahul Dada Mahadik, Secretary of Sri Venkateswara Shikshan Sanstha, Professor Mahesh Joshi sir, Director of Sri Venkateswara Shikshan Sanstha, Principal, Vice Principal, Dean, all HODs and all their participants. We warmly welcome you on this occasion. We are from Sri Venkateswara Shikshan Sanstha, the institutions that have made a name of excellency for themselves with a quality education, which is localized as Sangli, Satara and Kolhapur district from Maharashtra. In a decade of journey of Sri Venkateswara Shikshan Sanstha, we are proud of successful institutions, expansion with various 12 branches. Once again, I welcome all of you and I request to Head of Mechanical Engineering Department, Professor Javed Tamburi, to few some words on this occasion.
Uh, Thank you, Gurupati sir. Okay, good morning, one of all. Myself, Professor J.M. Tamburi. Now I'm so overjoyed to take the opportunity to introduce our department. First of all, I would like to welcome our Principal sir, Dr. A. Mirjes, Executive Director sir, Professor Mahesh Joshi sir, and expert speaker, Dr. P.R. Apte from the College of Engineering, Pune, and all participants of 1 week faculty development program on advanced research methodology. Mechanical engineering department established in 2011, and more than 800 students have been graduated from mechanical engineering department, and they are working in various organizations, and many students started their business. Our mechanical engineering department have currently more than 440 students with young and dynamic qualified staff, along with 18 well-equipped laboratories. As as a part of student activity, our department student design and manufacture a go-kart model along with the number of social activities are organized and participated by students during this pandemic situation. In this academic year, from the final year students, more than 78 students and faculties published a paper in various well-known journals. So we are taking initiative to encourage research activity through this program. At the last, I hope all of you attend all the sessions and get maximum benefits from this program. Thank you. Varpati sir?
Continue further.
I'm over.
Hello. Hello.
चालू करा सर, कंटिन्यू करा.
Hello. Hello.
घोरपडे सर और शिंदे सर, कंटिन्यू द फर्दर.
Hello. Hello.
Yes, you are listening, sir.
Thank you, Kambol sir. Myself, Professor D.D. Patil from Mechanical Engineering Department. Here, I will give the brief introduction about this, our 1 week faculty development program, which is based on advanced research methodology approved by IST New Delhi, approved by AICTE, and also in association with Mechanical Engineering Department from Nanasaheb College of Engineering, Peth. So, as we know that there is a need of the research methodology for our research work or PhD work, and with this we have arranged this 1 week FTP, which is based on advanced research methodology. Our objective or the motive is of this project, this FTP is to provide the overview of research methodology to help faculty and research scholars to define the research problem, to insight different research designs, to guide researchers in writing the research paper. And with this objective, our area of the focus is nothing but the defining research problems and getting world-class results, research design process, data processing, mathematical modeling and analysis, research and 3D printing, effective paper writing for referred journals. And for this FDP, we got some special resource persons from different institutes. On the first day, means today, 26 July 2021, our resource person is Dr. P.R. Apate sir from College of Engineering, Pune, and his today's subject is defining the PhD or research problem and getting world-class results. On the second day, Dr. M.T. Telson sir from Vice Chancellor Sanjay Ghodawat University, Atigre, and his title is, or title of the subject is Research Design Process. Then on third day, Dr. V.S. Kothawale sir, Professor MIT World Peace University, Pune, and his area of, or title of the subject is Data Processing, Mathematical Modeling and Analysis. Then on the fourth day, Dr. S.S. Kulkarni sir from PUPIT, Budgaon, and his title of subject is 3D Printing and Research. On the fifth day, Dr. S.R. Desai sir from RIT Sakrali, and title is How to Write the Research Paper and How to Publish the Paper. So these are our resource persons and their title. So once again, I welcome all the dignitaries, also all the resource persons and all the participants for this FDP. I hope you will enjoy all the sessions. Thank you. Thank you very much. Thank you. Now I would like to request Dr. P.R. Apate sir, Professor, College of Engineering, Pune, to start their session. Thank you.
Good morning, everybody. Thanks to Dr. Vishwajit Chenge. Good morning. Good morning. Thanks to Vishwajit Chenge sir to invite me to this because he was a PhD student when I taught this course on research methodology at COEP a couple of years ago. And thanks to NMCOE College for arranging this, very, very relevant subject of research methodology for PhD and the postgraduate scholars. So, do I have the privilege of presenting my PPT?
Yes, sir, you can present, sir.
Are you starting the recording? Somebody?
Yes, recording started, sir.
Is it recording already? Okay. So let me present my PPT. I hope the participants are seeing it.
It is visible, sir. It is visible. Okay,
So what I will do is, I'll just go full screen. So is it full screen now?
Yes, sir. Yes.
And please, I request all participants to put the mic on mute. Only when I ask a question to the participant, they can unmute temporarily and then give me some feedback, answers. So good morning to all participants. I am Prakash Apate. Presently, I am retired from IIT Bombay and I am doing visiting professorship at COEP. Earlier to the COVID situation, I used to physically go and teach courses, but now we do it online. So the course I teach at COEP is called Creativity and Innovation. And I think both are these keywords are very much useful for doing research. But the theme of the course is research methodology. Let me say something about research methodology. So why do we need a systematic way of doing research? Because research is supposed to be something original and something others have not done as a PhD problem. So is a systematic method going to achieve the desired results? Or why do we require a systematic method for creativity and innovation? So we normally feel that this creativity and innovation are ideas which suddenly come to your head and then you implement and you get wonderful results. While it is true, it may so happen, but we still want to follow a systematic method for doing research. The reason is simple. So when I used to meet my PhD students, I used to ask them, Dhananjay, what did you do today? And then he would say, I got up and then I brushed my teeth. I said, no, I don't want to hear all those morning duties. Tell me, what did you do for your PhD? And then he used to say that, sir, whatever you told me I have done yesterday, you told me I have done it today. So this is one of the methods for doing PhD. This is a systematic method that the guide can tell you every day what you have to do. And the guide will ask you every evening, 5 o'clock, 6 o'clock, a fixed time, that student, what you have done. So this is one way of doing things. But now in the modernity, and particularly in the case of increasing teaching load for all faculty, including your guide, it is not possible that the guide will interact with you every day and is not going to tell you what to do every day, and then you do it and then go back to him every evening, say that, oh, I did it, or I had this problem, and that. Then the guide will tell you how to solve it. It's not going to be like that. So whole process of defining PhD problem, whole process of solving that problem is all unto the student himself or herself. And we interact with guides only once in a week or once in a fortnight, or when there is a good result or when there is a problem. So whole idea is that we have to make this systematic so that the PhD scholars become independent. And once you are able to do that independently, then there is fun also. Because otherwise, as in Marathi we say, you become a sankamya, and then there is no fun. Because every day somebody tells you what to do and then you just follow it. So I think just to keep the interest and motivation and fun, we have to actually take part in even defining the PhD problem and not believe that the guide is somehow going to give you the PhD problem. So let's see in this way that it is good to be systematic so that you will get some quick, good results. And I'm going to actually emphasize more on getting a good, quick PhD, because we feel that following a systematic method actually takes more time, but it is exactly the opposite. If you follow the research methodology, I'm going to tell you some today, and you're going to hear from others in the next 4 days what is the research methodology key points. But if you follow the systematic way, it is actually going to be faster. And you have to believe me, and since you are attending this course, you already believe in it, that there is a thing called research methodology which will help you doing the PhD, a good PhD and a quick PhD. So my title is here, defining the PhD problem. So the first goal of my research methodology should be actually to define the correct PhD problem, what you can do or what you have to do. And having done that, then I have to actually get world-class results. This world-class is very important, because unless you get world-class results, you are not going to be able to publish your results in international top refereed journals. And nowadays, all universities have this requirement that you have got 2 papers published in journals of repute. And therefore, the first part of my lecture is going to be in defining the PhD problem, and the second part will be on doing a world-class research, world-class results. So this is my first slide, the research methodology for defining the PhD problem. And this is the part 1, approximately half, about 40 slides. And then I am going to take a 1-minute break for you and everybody. And then we will begin again after 2-3 minutes for part 2, which is solving that problem. This part 2. So for solving problem, I'm going to tell you a new methodology, which you may or may not have heard. It is called a TRIZ innovation methodology for solving any problem that you have already defined. So that's why the phase 1 is very important. The phase 1 is to define the problem, a good problem, correct problem. And then in the phase 2, I have to solve that problem. But for solving also, we need a systematic method, and therefore I have actually initiated this, what is called the TRIZ innovation method. So TRIZ innovation methodology is used for solving that problem. So therefore the lecture is in 2 parts. One is for defining the problem and one is for solving the problem. So this is the outline. So first of all, what is the need for innovation or invention, as we call it? So the need for innovation is required in defining the problem as well as in solving the problem. So that's my first part. The second part is going to be actually to tell you in a nutshell what is the research methodology. So this is a systematic step-by-step process which you and everybody should follow. You meaning guide and you both should follow this, because we should actually agree that the guide and student both agree that this step-by-step procedure is going to be followed. So unless both of them agree, it won't move properly. Otherwise, guide will say, who told you to do this and why are you doing this and so on. So I think the research methodology is a step-by-step process which both guide and students agree, and therefore we have to use that process to first define the problem and then solve it. So definition is a straightforward, like a computer program chart. You go and define it, and then iteratively you have to do the work on it, solving the problem. So it is iterative. That means you have to do it several times. So you do it 2 or 3 times, and every time you do, and you get a world-class result, you get a publish a paper. And if you publish 2 papers, I think your work is very good, and therefore it is good enough for PhD. Then the third topic is in the part 2. So all the first 2 are in the part 1. The part 2 is the TRIZ tools for defining right problem as well as solving that problem. And TRIZ tools for solving the problem, and I'm going to take 2 such methods for today, and I'm going to demonstrate that how cleverly, intelligently it solves that problem and you get innovative good results, and which are good for publishing in good journals. So that's the agenda today. So let us move. So the first step. So what is the need for innovation or invention? So let me actually describe this terminology. Invention is something that you do which nobody in the world has done, and then you can actually file a patent, okay? Or there are many ways of doing this patenting in India as well as abroad. So you can patent the process, you can patent the design, and you can have take a patent on the idea itself. And some countries don't allow ideas to be patented, but some countries allow. And therefore, the invention is something that nobody in the world has done, and then you can file your patent. But innovation is also an idea. It's also coming from your brain or head. The idea is a good idea. It need not be your original or first time in the world idea, but you have seen somebody else using a good idea, and then you actually use it in your technology. For example, some good idea from civil engineering can be borrowed by people in mechanical engineering and vice versa. So that's called innovation. And therefore, for innovation, the key word is that it has to be implemented. That idea is to be implemented in something which is very physical. That means you have to actually get results. So idea is an abstract thing which is in the head, and innovation is actually a physical implementation of that into something that you can feel, touch, and see, and get some work done. So it is a manifestation of that idea in the physical world. And therefore, for engineering student, I don't have to elaborate on that. For an engineering student to finish the PhD, he has to actually implement that idea, that PhD problem, and actually make some engineering product or engineering process, and then show good results. So that means there's a physical manifestation of that idea which actually agrees with what you wanted to do, or agrees with what you said that it would do, what is called an hypothesis. So every PhD will have an hypothesis by which you will say that if I do this, I am going to get a good welding, or if I do this, I am going to get a good mechanical property or a good function. And that's called an hypothesis. And then we need to prove it by actually making things. So we have heard this phrase, necessity is the mother of invention. So what is the necessity for doing PhD? Well, I'm going to come to that. very soon. I will like to ask the participants some question on that, but let's move further now. But what is the necessity for innovation? So invention we can understand, but what is the need for innovation? So that is called frustration. So frustration is the mother of innovation. This is my version of it. So when some journal paper or a textbook says that, if you do this process like that, you will get this wonderful result. Or when you do this like that, you will get a very good welding. But the frustrating part is that when we actually follow all those steps, it doesn't give me a good weld. It doesn't give me what it says that it will do. For example, I have so many taps in my house, and I want the tap to perform two functions. One is open and close water, and the second function is to control the rate of flow. So suppose the rate of flow is okay, but opening and closing is a problem. The opening is fine, but closing is a problem because it leaks. So whatever I try, the leak doesn't stop. That's called frustration. And therefore, this frustrating business actually requires some, physical implementation or ideas which are real, down to earth, which have to be actually physically done, and then we have to remove that frustration. So I am yet to see a tap which anybody makes, which is leak proof. So over a time, we all know, all the taps in our house actually made of brass and so on, well, after some time they start leaking, drop by drop, and then it increases, and then we have to call the plumber, and then he will fit a new tap, because now concept of repairing taps is gone. So now we have to only replace with a good tap. So I think in the first phase of your PhD work, this frustration will become the important aspect, because whatever you read in the literature, for some reason, you are not able to do it in your own laboratory. And that's frustrating. And then you have to still find the answer. So innovative ideas are required to find those answers. And therefore, we must actually follow some systematic way, innovative practices. Please mute participants. This is Tamil for you. Organizers, can you mute everybody?
Sir, unmute yourself, please. Sir, please unmute yourself.
So I have to now start sharing again. So are you able to see this slide again?
Yes, sir.
Singhe sir. Okay.
Yes, sir.
I think the participants should be careful. So otherwise, the whole family, is talking on somebody's mic. So I go to the next slide. So necessity is the mother of invention, and frustration is the mother of innovation. So innovation is something when you do physically, we have problems and we are not able to repeat it, and that's frustration. And therefore, we are required to do something about it. So how to solve the PhD problem is the theme of my first lecture. So first, how to define the PhD problem, and then how to solve it, right? So first phase is how to solve the problem of the PhD problem. That means, how are you going to find the PhD problem? So my sequence is like this. So somebody tells you to start working on this topic. Either you select your topic or your guide gives you the topic. that okay, you can start working on friction welding. So there is an echo from somebody. So everybody's mic is a difficulty. Okay, so the topic is given by yourself or guide, and then the guide will tell you how to define your problem and then go to university with that problem and get registration, right? So along with the registration, you have to submit a few pages of explanation that what is your problem and how you are going to solve that problem. It is in advance. That what is the basic content of your PhD. But having done these three things, will actually, we call that the problem has been defined, because the problem has been defined and it has been registered with the university. So registration is the first phase of your PhD activity. And the registration is a very important one. So this is what I call how to solve the problem of finding the PhD problem. Okay, this is my first part one. The second part, having defined the problem, you have to publish papers in good journals, and then only it becomes a finish of the PhD. So unless you are able to get good results, world-class results, and publish 2 top journals, your PhD will not be granted. So that is the second problem. So first is the register with the university as a PhD student with a topic and give a very general outline of what you are going to do. And having done that, then within the next 2 years or 3 years, you have to be able to publish 2 good papers so that your PhD is now possible for you to submit the PhD. So now I go on a question. I ask myself questions like this, and this dialogue actually came about when some student from nearby college from Pune, nearby city, came and was trying to register for PhD with a COEP professor. So when he met me, I asked him that why do you want to do PhD? So the answer was that he said he must do PhD. I said, why should you must do PhD? So he gave me some answer. So I request the audience to give me an answer. Why do you think that you must do PhD? Give me one answer. Anyone? Unmute and tell me why you must do PhD. Participants, are you able to hear me?
Requirement, yes.
Requirement for what?
Might be the requirement of the faculty to get registered.
No. But why you have to do PhD first of all? Otherwise, I don't want to do PhD. I have done ME or MTech, and that's good enough, no? To become professor in college.
To get the depth knowledge.
Okay, one is to get advanced knowledge and become an expert in that subject. Okay.
To gain expertise of the particular domain so that we can make our career into that field.
Okay, this is a noble answer. I want a more practical answer from somebody. Which is important? I must do PhD. That must has to be explained.
Because to take a doctorate.
But why? Why you have to do it?
So, sir, my answer is to solve the particular problem in respective domain. That is the main intention of the PhD.
No, that is the noble answer. The practical answer is that your career path is not clear unless you do PhD, right? You will not become a full professor or you will not become head of the department and so on. So there are 2 aspects of it. So one is everybody knows that sooner or later PhD will be required to have your career path going all the way to the full professorship or head of the departmentship, etc. The second one is a more noble answer, that you want to increase your knowledge in a particular topic, you want to become an expert, and then even later you want to guide PhD students. So unless you do your own PhD, you cannot guide PhD. So must do PhD. Okay. So I told him that there are so many musts, that a particular person who has done MTech and has already spent 2 to 3 years already in college. So he is somewhere in 25, 26 years, has just got married. He has got a kid. He has got parents. So there are so many musts in his life. What is that? He has to first financially provide for them and take care of the elderly parents' health and other issues. And then he has to also be nice with the in-laws, and any of these problems at home will also become a must activity. So PhD will remain as one of the must activities. So for example, the parents fall sick or something, he has to stop PhD work and attend to that, right? So a must do PhD, this must word actually competes with other musts in your life. So I always say that if you feel that you must do PhD because otherwise your career path will not be guaranteed, then it will take 6 to 8 years. I have several examples. So many people actually take more than 5 years, and it becomes a problem for the guides also to keep on explaining to the department why the PhD student is taking so much time. And generally, the most likely answer is that he has taken off, did nothing for 1 year because of some other problem at home, some other problem because of the situation at home. So we should not say that I must do PhD. We should say, I should do PhD. For example, I told that person who came to COEP from a small place nearby that COEP has got excellent facilities, good guides, and you can come and do the work here, and you have access to good library, you have access to good equipment, good fast computers. So actually you should do PhD, because now if you are able to interact with the guide, then it will take 4 to 5 years. Because now the PhD is connected not only to your requirement of your career path, but now it is connected to the facilities which are available at the place you register for PhD, or where your guide is. And therefore it is a little faster work. But that is because the place you are going to do PhD should have appropriate facilities. That is why, if facilities are there, you should do PhD. But even better is the third one, that you want to do PhD. Like the first answer I got from one of the participants is that he wanted to do PhD to become an expert in the topic, and then be able to guide other PhD students later on. So if you want to do PhD, in spite of so many other responsibilities, you will be able to focus on doing it. And if you want to do PhD, I guarantee that it will take only 2 to 3 years for doing PhD. Once you register, after that, it is going to finish within 2 and 3 years. So the whole discussion today, now already about 1 hour, 1.5 hours remaining, more than for 30 minutes have already gone in discussing this rough, psychological things. So in the remaining 1.5 hours, I will tell you how to do it in 2 to 3 years. So when I talk in my part 2, that how to solve that problem, I will be focusing on this aspect also, how to solve that problem in 2 to 3 years. And within this 2 to 3 years, I should get 2 international journal papers published. I'm going to come to this aspect, that if I want to do PhD, it's going to take a short time, because you are really motivated. A must means you are forced to do it, right? Must means you are forced to do it. Here, should means you are encouraged to do it by somebody else. The guide is encouraging you or something. But here, you are yourself motivated, that you yourself want to do PhD. and therefore it will take a shorter time. The question is how to do it in 2 to 3 years will require to answer this question. So how will that happen? That you are motivated and you want to do it in 2 to 3 years and get world-class results and publish 2 good papers. So question is how to do it. So the remaining part of the lecture is for this, how to do a very good PhD in a very short time, 2 to 3 years after registration. Let's see. So we already covered the first topic here, and now we go to the second topic, the systematic method or step-by-step method of proceeding with your PhD. Okay. So this is the second topic we start. So research methodology for defining the problem as hypothesis. So I'm going to give more emphasis on this word called hypothesis, and I will explain to you what the hypothesis is by my own successful application of such an hypothesis in my personal life. But let's see the step-by-step method, which is called research methodology. So research methodology in engineering and science, engineering is on the left-hand side and science on the right-hand side. It is like a flow chart that we normally write in when you write computer programs, simple computer programs. So science, I'm not very much keen, but we will actually do the engineering one. So I now copied this engineering one here, and therefore we can now see that the flow goes like this. So first select the topic and the guide, correct? Select the topic, guide, and then the next one is a literature survey, and the next one is to specify what requirements are to be there for your engineering product. So let me go further. So I want to construct a research hypothesis. So research hypothesis means a general hypothesis is a statement, something like if you take some giloy and some other medicines which are given by Ayurveda. So giloy and let's say some other honey and so on. So all these things, we say that if we take these medicines regularly, it will increase your immunity and you will not catch corona. So this is called a statement, right? So this particular 2-3 things if you do, corona will not be infecting you. So you will actually escape from that corona. But question is this hypothesis true? That means you have to prove that this hypothesis is true or false. So then we have to do experiments and trials over people who are actually participating. Say hundreds of people are participating in this. And then we prove that yes, these medications will help. So 90% of the people will not catch corona. Only 10% will catch. And then there will be another 100 people who have not been taking this medicine. Then 50-60% of those people will catch corona. So the same thing was done. The research hypothesis for the case for creating vaccines was also same. That somebody gets an idea in say any particular laboratory, and then they say if we do this, it will create a vaccine. But that is an hypothesis. Then they have to actually try it over a large population and see people who take that vaccine, 2 doses, and people who don't take that vaccine, and then go in a normal life, and then they will actually 90% of those who have taken the vaccine will have no symptoms of the corona or COVID-19. So that's called a prove that hypothesis works. So research hypothesis also is like that. So how do we arrive at the research hypothesis? So what we do is we actually do literature survey. From the literature survey, we create gaps in the, or we find gaps in the literature. So something that people have not done. And then these gaps, if we concentrate on these gaps, then we say that our research hypothesis is we have to do experimental work or simulation work or whatever the engineering practices you want to do is to actually fill these gaps in literature. So this is called the hypothesis. What is the hypothesis? I do literature survey, then I find what people have done as well as I have found what people have not yet done. This is called gaps. And once I say that I have found 4 gaps, then I'll say if I work on filling up these 4 gaps, then I would get a PhD. So that's my research hypothesis. The only thing is I have to now do it actually in real practice. So I have to have ideas and then evaluate ideas, then choose a solution, then develop prototype, and then test the prototype, and then see whether that hypothesis is true, whether by filling up the gaps, the whole process or the product became better. So this is called get ideas, then do things with it, and make a real engineering product, then test the product, and then decide whether the solution meets the requirements. Requirements means it has solved the problem, and then communicate the results to international journal. If it has not, then you go back and redo it again, right? Redo this part or only this part or only this part. And this is called iterative process. The whole idea of this iterative process is to find out whether my research hypothesis is true. And my research hypothesis is do literature survey, find the gaps, and pick up 3-4 gaps, and then we say if we fill in the gaps, the whole process will become better and I'll get better result. This is the hypothesis. So I will tell you my own personal story of one hypothesis I made for myself, and then I kept working on that hypothesis. So same way, hypothesis. And then I did things here and kept on trying it till I got good result. So my hypothesis was very simple, like this. So I said that we know that we have this, before the COVID-19, we used to have the normal virus, what we call the flu virus, or we have a very normal thing in the monsoon season. We get wet and then we catch cold, and our nose starts running and our throat starts paining, and then we get cough in the chest, and then we have fever. So we say that this is a series of activities which we assign that to virus. And you know that for virus there is no medicine. So virus you have to only have immunity. So the medicines we take for these situations is only to ease out the symptoms, right? Symptoms is running nose, throat is paining, the chest has got cough, and you have got fever. So all the medication that you take is for the symptoms. So for the virus there is no medication. So I said this is not a great idea. Every season, every monsoon season, I get this and I fall sick, right? Our children go to school and they fall sick every rainy season. So once they become wet, when they come home, by that time they are already sneezing, and the same night we will have them having some fever. So this is a problem. So let me find out a hypothesis. So I made an hypothesis, meaning a statement of something that will prevent me from getting virus. So I said that there are only 2 inputs in our body. So one is the nose from which we breathe. Normally we don't breathe through the mouth. And the other one is the mouth and the throat. So we eat something and things go in there. So either from the nose thing can go in, or either from the mouth something can go in. Of course, there are eyes also where some things can go in. But fortunately, the liquid that comes into is all the time lubricating our eyes is sufficiently antiseptic, let's say, so that the things don't actually go through the eyes into the body. So antiseptic lubricant which is there in the eye will prevent it. The ears are having a drum, so there is no opening there. And then, so I said that the hypothesis is that if these two inputs, the nose and the throat, if I can control and I can make them robust, then I will never get sick. I will never catch cold. I will never have throat infection. I never have cough in my chest, and I will not get a fever. So question was how to do it. So I had to get some ideas here. So my first idea was to start taking cold water bath and get wet in the rain every day. So in Mumbai, I was in Bombay. So rains heavily almost every day. So I used to come home and then go without umbrella and go with a dress, go out, walk for half an hour, come back, remove the wet clothes, and then take a shower. So this way, I get used to the rainy season. I get used to the water which goes on my head, and therefore the most likely reason for catching cold is that, right? The rain and the cold water. But one of the main problem is not only this, the main problem is that you go around with wet clothes for more time, half an hour or 5 hours, or afterwards you go to place, I used to travel to place of work, and then if I get wet on the way, then I have to remain with this wet clothes for 5-6 hours, right, at the workplace. So I changed that habit. I used to keep dry clothes at the workplace and I changed there. So the main thing is to avoid getting infected is to avoid the wet clothes and get used to the rain and the cold water. So I started taking cold water bath every day, even in the winter. Now I am in Pune from 2014, already 7 years. So Pune water, the weather is very cold compared to Bombay. And I still take cold water bath even if temperature outside is 8 degrees, 10 degrees away. The second one was the throat. So what do I do with the throat? So I used to get up and take a ice cube from my freezer, and I used to suck on that ice cube every morning. And therefore I have to make my throat robust so that it doesn't get affected by the cold things. The same way in the evening when I eat, I used to take the curd or yogurt from the fridge, and I used to eat 2 spoons of that while it is cold, because it has got soreness as well as it is cold. It is one of the worst things that you and I find is bad for the throat. But I have to make my body robust, and therefore I did these 2 things for almost a year, and I still do it. So this I started in 2001 when I was 55-year-old, and now I am 75-year-old. 20 years later, I can tell you that I didn't fall sick even on a day. I don't fall sick. I don't catch cold. I don't have running nose. I don't have sore throat. I don't have heavy head. So I am now become healthy. Everybody in my family or my surrounding is catching these viruses every year, but I do not get that. So now my research hypothesis was that if I take care of these 2 inputs of my body and make them robust against cold things or sore things, then I will not catch the virus. And therefore it has, by experimentation with my body, I have now done that and I have proved it. And you can see I am healthy. So now I am no more afraid of catching cold and all that, last 20 years. So same way, you have to make an hypothesis, a research hypothesis. And I have now made for you the research hypothesis. What is the hypothesis? When you do literature survey, first 3 months, find out what people have done in that topic, and also simultaneously find out what they have not yet done. And these are the gaps. Now we say all these gaps I want to fill. I want to actually make the process without these things which others have not done. So I will do it. And then I say if I find 4 gaps, then I put it part of my research hypothesis that if I fill in 4 gaps, then my PhD will be done. That means I will get world-class results by doing this process, and then I will be having a solution which meets the requirement that the gaps are filled, and then I can publish the papers. So this is the whole idea. The research hypothesis is if I find 4 gaps in my research topic, then hypothesis is that if I fill in these 4 gaps, then I would have got world-class results. So this is the iterate. So we have to get ideas to fill in these gaps, one gap, 2 gap, 3 gap, 4 gap. So all these things we have to do. Then we have to actually make experimentation in the laboratory or do simulations, and then check whether the ideas that we had actually work. So the gaps are filled. So I'm going to take some example and show you how these gaps are filled. So this iteration is a repetitive process, and for 1 gap we'll do it, for 2 gaps we'll do it, 3 gaps, 4 gaps. So like that is the continuing process of your PhD. And as we do this, within 2 to 3 months of doing things with that particular goal, the hypothesis that if we fill in these gaps, I'll get a communication of a paper, right? I will be able to publish a paper. So once we get this thing, then every 3 months, 6 months, we'll actually get good results, and then we'll be able to publish. And therefore, I don't think it's going to take more than 2 years to get 2 papers out. So on average, I will say the first paper takes for 1 year and the next paper takes 6 months. So within 1.5 years itself, you would have got 2 publications. So when I have my PhD students, within 3 years, he gets almost 5 papers out. So there is no real stopping you once you know exactly what we have to do. And the idea was exactly the same, that the gaps in the literature actually is the key to make the hypothesis that if we fill in these gaps and avoid these negatives or whatever they're not done by others, then it will be my PhD. And therefore, this is the way my hypothesis goes. But now, since it is step by step, I'm going to tell you how to do this, how to do this and this in a systematic way. This is the research methodology part. So research methodology is very simple. So let's concentrate on literature survey. So we begin by selecting the topic. Of course, we don't know the PhD problem in that, but guide and you have agreed to select the topic. Let's say welding of 2 parts. So is my topic. Then I do the literature survey, and what it includes is reading textbooks, monographs, review papers to understand the basics of that topic. Then to understand journal papers and patents, which are more advanced things in that topic, what intelligent people world over are doing, patents, and then get involved and study all tools and techniques for actually what others have done, right? For others have done these papers as well as patents. So what are the tools and techniques they used? And then we have to also get used to study all these tools and techniques. Now, this is only a 3 to 4 months activity. We should not take more than a year or something like that. So my thing is that while you read 20, 30, 40 papers and some 5, 6, 10 patents, it's necessary for you to find out those top 6 to 10 papers and patents, which will help me to create my gaps, right? 4 gaps. I want to find the 4 gaps in the literature, which is my PhD hypothesis, right? The hypothesis is that if once I find the gaps, I'm sure that my effort should be directed to filling up these gaps so that I'll get my publishable good results. So what do we do when we read the papers or patents? So in the papers, we read that from high impact journals and with many citations, these papers, we should clearly point out what are the flaws in the prior art. Prior art means whatever is the existing literature. So flaws means some negatives, something that they have not done. And then where there's a big list, I will give you my PPT as PDF, and then you can read this. All these are the basic activities which are required in the literature survey. So most important is discussion and conclusions. So in papers, we should read discussion and conclusions, because that is where the authors usually tell you what they have not yet done. And therefore, to find out what they have not yet done, discussion and conclusions are the one place. The rest of the paper is in only discussing what they have done, right? So what they have done, we want to know. but we really want to know or read between the lines as to what they have not yet done, meaning what are the gaps. Then we take the most important discussion, and from that we can find the gaps. And then we have patents. In the patents, we have to read this background of the invention. So the patents has got very simple. It has a title, then the name of the inventors, and then there is an abstract. And after the abstract, there is a paragraph, what is called background of the invention. So background of the invention gives a short summary of prior art, that means whatever is the previous science or technology. But the aim is not to glorify the prior art, but instead it points out to the problems, flaws, harms, limitation, drawbacks, etc. in the prior art. So it says, oh, all these people have done, but there is still a problem, there is still a harm, there is still a limitation, there are still drawbacks. And the last sentence, usually the last sentence in the patent, is that prior art has got this and this problem, and my invention described below has solved it. So that means they have already listed several problems, but they have taken that one of that problem and solved it. That means the remaining of them are not being attacked by the patent. Only one problem of that. So this is a very small thing. It is less than 1 page. It is maximum 2 paragraphs, and it is a gold mine for problems in the existing literature. And patents you can read from 2001 onward or 2005 onward. So these are the latest patents in that. So the latest list of problems and limitations and drawbacks in the existing technology are easily available in the patent. So therefore, literature survey is not complete unless you read patents. Because my hypothesis is to find what are the problems, harms, limitations, drawbacks in existing literature. So those are the gaps. And therefore, from the point of view of that hypothesis, I should read patents. So now we are going to do is to define the right problem. Correct? The first hour is almost getting complete. So I should now tell you how to define the right problem. And the right problem is having the clarity with which we have already found the gaps in the literature, right? So define the right problem is you have already found the gaps in the literature. So let's see how to do it. This method also allows you to do that, which is the problem solving method, but it also allows you to define the problem. So TRIZ is a method of Russian origin called the inventive problem solving, and it allows you to formulate the problem using a tool called ideal final result. So what is the function and what is the ideal final result? And if a paper or a patent is not getting the ideal final result, that means there is a gap. So to find out what is the gap between existing technology and what is the ideal final result, we can find the gaps. So let's see what we do in this. So this is the problem finding part. So I have taken an example for mechanical engineering. So the process I want to study for my PhD is welding 2 parts. So there is a part 1, there is a part 2, and this is the filling material, which is giving me a good weld. So what we now define is the ideal final result. So ideal final results are in 2 parts. One is called the main function. The main function is welding these 2 parts is to join them so that whatever you do, they will not get separated. You know, it's a good weld. So ideally, it is having infinite strength, right? So if we have a tensile strength, we pull them apart, then we want to define this in an ideal welding if the tensile strength test gives me infinite strength, right? Of course, we will never reach the ideal, but what it means is that the tensile strength should be very much larger than the tensile strength of the basic material here. So when we pull these 2 parts, this part should break and this weld should not break, because this weld already got a large cross section. So if welding is good, it will never break, and only this part will break. So weld should never break. That's the whole idea. But there are some negatives about ideal things. We call them harms. When we say there is a harm, then ideal value is 0, right? Then we have a problem of this material which is welded here. It has got micro cracks. So if it has got micro cracks or a number of micro cracks or a large length of micro crack, then my welding strength will be reduced. So it says no micro cracks. Then if my material has got voids, then it will say no voids, because voids will also cause me to get a reduction in my tensile strength. So these are the engineering tensile strength parameters. But there are visual parameters of a welding. So there is a burr or uneven weld, then also we don't like it, correct? Ekdam German weld hona chahiye. It should look beautiful. Then there should be no warping of these plates, right? These plates have got a rectangular thing here as well as here, and then they should not go out of shape. So these are the visual things, and these are the engineering things. And these engineering things are related to the strength we measure. So we now have 4 harms. Now we have to see whether somebody has identified in the literature these 4 harms and have anybody done anything about it. So we now start our literature survey with this list. So list number 1 is the main function, a large tensile strength. And the harms, the micro cracks are harms, voids are harm, burr and uneven weld is a harm, and warping is a harm. And then we will start our literature survey with this view of doing these 5 things. And let's see in the literature survey, author or the paper number 1. Does the paper number 1, does it discuss increasing or doing something about improving tensile strength? If yes, then I'll put a tick. Is it doing anything or telling anything about reducing micro cracks? Then I will put a tick. Is it doing anything reducing voids? Then I'll put tick. Is it doing reducing burr or excess weld material? Then I will tick. Is it saying anything about warping? Only then I will put tick. So like that, I do it for every paper. So I now critically examine all good papers. No, they're in good journals and they have got a lot of citations. And then I will put ticks only if it does. For example, this paper is basically trying to increase the tensile strength by reducing voids. That's all. It doesn't talk about micro cracks. It doesn't talk about burr excess and warping. Paper number 2 is not talking about tensile strength. It is talking about reducing micro cracks and reducing warping. So like that, several papers. And then this patent is only trying to reduce micro cracks and voids. It is not doing anything else. The patent number 2 is trying to increase tensile strength and simultaneously reduce this excess bulk. Because excess is not going to help in increasing tensile strength. If you are familiar with welding, the basic filler material should be less. If you put too much filler material, actually the weld strength goes bad. So we have to now worry about this strength, tensile strength versus this excess of filler material. And that this pattern does good. So minimum material, filler material, the best tensile strength. Now once we get this chart filled up during our literature survey, about 3 months, then we will say in these 3 entries which are there, what is the best value? Then we actually put this value, the best value here. So like that, if this is the best value from paper 1, then I am going to write this value here. So I am going to complete this research table, my target, this is my target, what I have to achieve in these 2 to 3 years. The same way I will now do it for the row number 2. If this is the best value in all this row, then that I substitute here. So I now get at the end of my literature survey a table, a research table, which actually gives me the best results available so far in these 5 things. So one is the basic function, that very large tensile strength, and the others are the harmful functions. So they should be as little of micro cracks, as little of voids, minimum burr and excess, and minimum warping. While ideally we say 0, 0, 0, but here we say minimum. So these minimum values of harms are here, and the maximum value of the tensile strength is here. So my literature survey is now complete with respect to my gaps. So these are the gaps. So how do you find the gaps? So now as an example, I'll just go through paper 1 and paper 2. These are the top journal papers with lots of citations. These 2 papers together are accounting for welding strength, micro cracks, voids, and warping. but both of them have said nothing about the excess or burr. Correct? So now that's a gap. That means these two papers discuss everything, but have not done anything about the excess or the burr. Same way, say this author here, author 8 and patent 1 have discussed these 4 things, but not discussed the excess, right? Or patent 1 and 2 have discussed these 4 things, but have done nothing about warping. So like that, taken 2 at a time, we can always find what it has not yet done, correct? It has done these 4 things, but it has not yet done this thing. So therefore, I can now make a brick wall. So it is the same graphical representation of this same table. For example, number 1 and 2 discuss everything except the harm 3. The harm 3 was the burr and the excess. Same way, paper number 1 and 7 will have discussed everything but not harm 2. Then paper 4 and 5 would have discussed everything but not harm 1. And so therefore, and paper 3 and 6 had discussed everything except that they have not tried to do anything about improving the tensile strength. So this is a one-to-one representation of this table into this graphical thing which is called a brick wall model. So this is like a brick wall. And therefore now my hypothesis is true. I have got this 1, 2, 3, 4 harms and 1 main function. So I got 5 things to concentrate on. And if I now fill up these gaps, right? These are the gaps. 4 arms are my gaps. So if I do this gap filling, then I would get a good PhD. So I start working within 3 months, 6 months, I'll get some result, right? Then I add 1 more column to all the previous table. So this my research table now with my results. 3 months, 6 months, different things I'll get. And therefore I keep focus on my results. And now I find that my value, which I got, is much better than this best value. So that means I did something, I followed paper 1 and 8 and so on, and then I found author 8 and patent 1, or whatever was this gap here, and then I find I get the best value. And therefore, if I get the best value, then I get another result which is a little better than the best value. This is very much better than the best value. And then I now ready with my literature survey. And now I put this table and then I can now publish. I can publish in top journal because I have got a very much better, very much bigger value than the best value. So for example, one of the high DC superconductor experiment I did, I got 10 times better value than the previous fellow in the critical current, 10 times better. So that is what means that my value is so much better that it will go in the top journal. And it did go in the top journal and I got 75 citations on that. So that is the value of focusing on something which others have not yet done. And I get a minor improvement or some improvement, but I use another different method, and then I can actually publish in a good journal, not the top journal, or I can publish in international conference. So this is the way, the first, once I do the literature survey and create this table, right? Once I create the table, once I am ready with this table and I am ready with this brick wall model, my literature survey is complete. And then I have to start working. And then once I start working, in 3 months, 6 months, 9 months, 1 year, I will get these 2 good results. And each of them is going to be, because all my research is already, all my background research, literature survey is already done. So I am now ready to actually write a paper because I have got everything. All references are there, the best value so far, and my value, which is much better than this. So this calls for a publication in good journal. And therefore, this is the strategy. Begin with the end in mind. The end in mind is publishing paper in a good journal. That's the end in mind. So my literature survey, finishing part of my literature survey, first 3 to 6 months, is to create these research tables and the brick wall model, find out 4 or 5 things I must do to improve the result, And once I get the good result, I'm ready to publish. So I think you will agree that we have begun with a focus. The focus was to find what people have not yet done and then do something about it, so that when I actually get good results, 3 to 6 months, I will get a publishable good result. So I will tell you as an example, industry, what it does. The industry does innovation, and I will now show you some slides at the end of part 1. So what industry does is it defines the right problem, whatever they want to improve, and they find 3-4 good solutions and then choose the 2 of the best solutions and then plan, experiment, develop best settings of parameters and obtain best results, and then the product is out. For example, the Gillette people actually did something thinking wise, that this is the old conventional blade made of good stainless steel. Only the 2 cutting edges are important, right? The rest of it is for mounting and all that. I have used it in my own time, but nowadays nobody uses this. So they said that why waste 90% of this good material, right? Costly material, while only these 2 cutting edges are important. So now it is possible that we can replace this thing by plastics, which have got good strength and moldability and all that. So plastic molding, just put these 2 cutting edges, and therefore the twin blade arrived. So the twin blade was a result of this thinking that only these 2 cutting edges are important. So put them and mold them in plastic, and then it will now work as a good shaving. So simultaneously both edges will be working on my shaving. Earlier only one edge used to work, either this or that. So now 2 edges are working, and then it became an instant success. And now there is no stopping after this twin blade. They come up with the 3 blades, and the 3 blades, it became even better. The reason is, if the hair does not get cut by the first one, it will get cut by second or by the third. Even if one of the blade goes bad, say number 1 goes bad, there are still 2 other blades which will do it. So the longevity of this blade system also is higher. What used to go bad in 1 week or 2 weeks, and now goes on for 3 months, and even bigger, more blades shaving systems are available. So now 3 is doing better than 2, and now we have this basic reliability calculation to prove to you that you will do well if you follow this reliability analysis. If probability of cutting hair by one blade, right, one cutting edge is 80%, or P is equal to 0.8, then the probability of not cutting hair by that single blade, single edge, is 0.2. Q is equal to 0.2. This is a normal conventional notation. P is for probability of success and Q is for probability of failure. Now, if we put 2 blades, then the probability of neither blade cutting is simply a multiplication of Q1 and Q2. And therefore, it becomes 0.2 into 0.2 is equal to 0.04. So, probability of neither blade cutting is 0.04. That means one of them will cut is 96%. Correct? So, now I have improved. By just putting 2 blades, I improved the probability of cutting from 80% to 96%, which is a big improvement, right? But with the 3 blades, the same calculation, probability of cutting and not cutting is, So for 3 blades, it will be Q1, Q2, Q3. So 0.2 into 0.2 into 0.2, it becomes 0.008. So that means 99.2%. So now I will say on any day that the 3 blade razor is much better, because the probability of cutting the hair now has improved. And I'm not getting any money for advertising this Gillette Mac 3. But I believe my calculation says that any one of the blade cutting is good enough. In that case, I will get one single stroke. The probability of cutting hair is now as good as full, 99%. So we don't need to put any more blades and so on. So what we have achieved now is, in the blade system, they actually got rid of that main improvement was to get rid of this unnecessary stainless steel material. But while they got rid of this basic costly material, 90% of it, they improved the basic shaving probability also. So innovation actually leads to many other advantages, what we call the bonus. So one is 90% of the costly material saving, and even all this metal is no more required, all is plastic welded and they are available, and therefore these are the most popular of the blades that are in the market. So what we should do for our own thing is that we should now say that I have got an idea of reducing harm number 1, okay, is 0.5. So probability of not reducing that harm number 1 is 50% again. So Q is 0.5. So if I now attempt to reduce all 4 harms, right, I focus on, whenever I do welding, I also measure micro cracks, I measure voids, I measure burr, I measure uneven weld, or measure the excess, and I also measure warping. If I measure all this, in addition, I measure the strength also. So 4 things, harms I measure, as well as I measure the main function, the tensile strength. So the probability that none of the harms will reduce, all negative thinking, none of the harms will reduce is 0.5 into 0.5 into 0.5 into 0.5. So 0.25 this and 0.25, 0.065. And therefore, probability that at least one harm will reduce is 93%. So now you see, you increase your chance from 50% to 93%. What I have done, I am not focusing on micro cracks only, because if I focus on micro cracks, there is only a 50% chance that after doing all the work for 3 to 6 months, it may or may not improve. So what I do is, once I do weld, I observe all 4 harms. So I must measure all these 4 quantities in addition to the 5th quantity, which is the tensile strength. So I only have this focus, or what I call my definition, or my hypothesis is that my process is going to make this micro cracks very small, voids very small, burr very small, and warping very small simultaneously. And I'm happy if even if one of them becomes reduced, then I got a good result. It's a world-class result. And now I may actually get my result better than the world's result, which is already there in my research table. So this way we have discussed the part 1. What was the part 1? That my hypothesis is the main function as well as 4 harms or 4 gaps in the literature will define my hypothesis, that if I do something about filling up these gaps, I would get my PhD. This is the hypothesis. Experimental work has to now prove this, that actually these harms will get reduced. And any one harm gets reduced, and if it is much better than the entry in my research table, I get a paper in a good journal, right? Top journal. If it improves a very minor improvement, but still an improvement, then it can go to a good journal or an international conference. So that's the hypothesis. Research methodologies has been followed. Literature survey led to the gaps, and the gaps led to my hypothesis, and it led to my experimental planning in measuring all these 4 harms. And it is likely to give me the best results, because now I have increased the probability that at least one of the harm will get reduced in a significant way, and then it is publishable. So now I will go to the second part. So IFR was used, ideal final result was used for defining this part 1 hypothesis. And now I am going to go to the part 2. So I will take a 1-minute break. If you like, you can also take. I will come back in 2 minutes, and then we'll take the remaining part of the problem solving, right? So this I am going to do in a little while. So I will now come out of the sharing. I'll stop presenting and we'll take a couple of minutes break and then come back. Okay? Because otherwise 2 hour lectures become painful for the speaker as well as the audience.
Okay, sir. We'll take short break.
Sir, break it like a hello, Shingi sir.
हाँ सर, शिंदे सर.
ठीक आहे, ब्रेक घेतला का मध्ये?
हॅलो. हो, येस. ब्रेक.
तांबोळी सर
ब्रेक घेतलेला आहे. हो हो.
ठीक
हो सर, ब्रेक
Yes,
घेतलेला
sir.
आहे.
Break is.
घेतलेला आहे.
ठीक आहे, ठीक.
Hello, sir.
ठीक आहे, ठीक. ओके.
Okay, audience, I'm back. Hope you are back too. So let me share again. So I'm back. Organizers, are you seeing my PPT?
Yes, sir. PPT
yes,
is
sir.
visible, sir.
Okay, voice is okay?
Yes, sir.
What? Okay. So let me summarize my part 1 by a simple dialogue I had with several people who are doing PhD in their 3rd, 4th, 5th year. And the dialogue goes simply, so I want to encourage them. So I ask them, how is the PhD work going? And then they say, oh, sir, well, my work is all done. But there is a problem. I said, if work is done, what is the problem? They say, I haven't published the papers. I had sent some papers, they got rejected. So the worst fear of a PhD scholar in his 3rd, 4th year is that there is now no publishable work. And therefore, what happens if you don't make a hypothesis like I have done, which is aimed at publishing a paper? What happens is that you keep studying and you understand the subject and you do a few things in the lab or do it on a computer. it's kind of repeating what others have done. And then there is nothing to publish. Even if you send something, the referee says nothing new, just 2-word review, nothing new, and it comes back. So we want to avoid that, right? So the hypothesis should be, we identify 4 gaps, the main function and 4 gaps, and then say that I'm going to fill these gaps. And these gaps are very easily available in patents. I told you, the background of the invention actually gives you all these gaps, and one of that gap the patent has solved. But there are several others which are mentioned there. So I think finding these 4 gaps is the classic way of beginning your PhD work and then ending up getting a good publication. The question is, how will we get a world-class result? The gaps are okay. I'm doing the welding and I'm getting all these measurements done for micro cracks and voids and the burr and the excess material, as well as the warping. And of course, I'm measuring the tensile strength. But the question is, how am I sure that this is a world-class result? So the only way is to, therefore, in your literature survey stage, right at the submission time, we submit it for registration, that literature survey table should be actually put as a part of the submission for the registration. And then you say, I'm going to do something about this, right? Filling up these 4 gaps. So I think let's begin on this. Now, what we want to do is to get a world-class result in a systematic way, in a short-term way, right? Quick way. But the quick doesn't mean it is a lopsided or a hodgepodge way. Quick way only means that my planning of the experiment and my planning of the simulation is such that I actually focus on all these 4 gaps. And once the focus is clear, there is no way we can miss it. So we want to now apply some innovative techniques for getting good results, right? So there must be a systematic way for doing the problem solving also. The problem is red and solving is green. So problem has to be solved in a systematic way. So one of the tools, systematic tools, is called TRIZ. So outline is TRIZ for defining and solving problem. We actually use IFR tool, ideal final result tool of the TRIZ, for defining that problem. The main function in 4 humps. And now we are going to use 3 tools: physical contradiction, eliminate harmful effects, and technical contradiction. And there are 3 other tools, but we will not actually touch upon those 6 tools. We'll only do the first 2 tools just to get you started, just to prove to you that there are very systematic ways of solving a problem. And therefore, we begin. So this is all about TRIZ. Who started this? Heinrich Altschuler, born 1926. He was working in a patent office. You can see that he was only 21 years old when he actually joined Moscow Patent Office. And he read thousands of, in fact, he read 40,000 patents along with his colleagues. And within these 2 years, he actually read large number of patents and found what he called theory of invention. That if you follow systematically what he found, we can actually do it quickly. That's what he found. So that is what we are also going to do. We are going to do something systematic. Yes?
Sir, PPT is not visible to us.
Is that so? Then what is visible?
Your camera is
just
visible.
pin to, sir, it is visible, sir. Just pin to that PPT.
Yeah, all participants, you should pin on my thing. All others are seeing it. Let me get.
Yes, sir. After pinning, your PPT is visible, sir.
Okay. My face may not be visible. It's okay, no? Yeah.
Your face is also coming in side window.
Good. So maybe 2-3 more participants. Are you seeing it? Participants are.
Yes, sir, it is visible. Yes, sir, it is visible.
Okay.
Visible, sir.
Let's begin. Let's continue. I think. Please All participants mute your mic. So there is a systematic way of solving problems, and this is what he called theory of invention. And he generated some 6 methods for solving problems. And I'm just going to show you a picture by which this will be clear. So your problem or topic given to you or selected by you and your guide is like a big elephant, right? A big animal. Elephant is a big animal. So there is a story about 6 blind people approaching an elephant. So if this one blind person approaches elephant and then touches the leg, he thinks it's like a tree. While another blind person first goes and touches the tail, he thinks it's like a rope, and so on. That means the topic is so broad that you and your guide, being from say mechanical engineering, will think it is a mechanical engineering problem. Some computer scientists will think that it is a problem that is to be solved by simulations and some package and so on. Some electronics fellow will think that that problem can be solved by some electronics or mechatronics and so on. So that means it is always okay for a mechanical engineer to solve it in a mechanical engineering way. Somebody else can solve it in an electrical way. All the welding apparatus. Somebody will solve it in a computer way. Somebody will solve it by using laser for doing this and so on. So that means it is up to you to approach that problem from any which direction, right? There are 6 directions. There are 6 blind people, that means 6 directions. So now TRIZ has got these 6 tools to solve any problem. So if you give your problem to TRIZ, I'm only giving introduction. I'll only take 2 tools. So this tool goes through a prism of TRIZ. So what does a prism do? White light goes through that. It splits into 7 colors, right? Whipjaw. So same way, your problem will go through the TRIZ tools, 6 of them. Maybe 4 of them are okay with you, right? 4 of them match. Now, each one will give me one result, right? Problem is of this type, it will give me a one result, right? Many alternative solutions to my problem. So the green one is my good result, right? It is a very simple thing that you do and get a quick result within a month. Within a month of identifying these 4 gaps, right? 4 harms and so on, you do something, you would get a good result. So one of the harm will reduce. But the orange one will take a little more time. This is called apparent or quick result. The orange one may be another one, which is called minor modification. So you may have to do a minor modification to the process of welding or to the apparatus itself. Then you will get a good result, which is better than this result. But it takes some doing, 1.5 months to 2 months. The blue one will take a major modification. It will take 3 to 6 months, and you will get a good result only after 6 months. Like measure the micro cracks better or measure the voids better. So it could be on the testing side also. Some good results are expected from improvements in testing apparatus. So like that, right within a month to 3 months to 6 months, you will get better and better results. So first one is a good result. This is better, and this is the best result. So we are now capable within 6 months to actually get several results from good, better, and best. And therefore, if our research table is ready with the current values of the best results, then we can easily see whether our result has improved, has become better than that or not. So this way the TRIZ is very good. I can apply 3-4 tools of TRIZ and then I will get it. The red one is very difficult to apply. Some TRIZ tool, though it says it can solve the problem, actually it will take 2 to 3 years for doing it. So we don't go that way. We stick to this first 3. A apparent or quick result, then minor modification and major modification. This is within a month, 3 months and 6 months. So you agree now that I'm telling you a variety of tools available with TRIZ which are likely to give me a quick result, minor modification, better result, and major modification, which takes 6 months, the best result. So it is all in the line. So we don't stop because we have identified 4 harms and say this one will improve one harm, this one will improve another harm, this one will improve the third harm. we don't know which arm, but it will improve in a bigger way. And therefore, this is likely to give you a quick result, 6 months. So my feeling is that if you are on the right track, you get result in 3 months, otherwise you don't get that result at all, even if you spend 1 year on it. So what happens in the frenzy of activity, the initial enthusiasm which you have for PhD is defeated if you don't get any result for 3 months or 6 months. Then your enthusiasm goes down, your activity goes down, and then it falls behind, and some other family must will take over, and then you actually lose several months at a stretch, sometimes even 1 year. 1 year you are not able to concentrate on your PhD, so which is bad. So best is to apply simple TRIZ tools, 1, 2, 3, 4. 3 of them will be something that you can do quickly, the green one, something you can do with minor modification, something you can do with a major modification, and then you are assured of getting continuously improving result, and your enthusiasm will build up. So we have to first define problem, which I already told you in part 1. Improve the main function and reduce the 4 harms, right? Improve the main function and reduce 4 harms. That's what I have defined as a problem. And method or tools to suggest solutions, I'm going to take TRIZ tools, 1, 2, 3. There are 6 of them, but today I'm going to only do 2 of them because we have got only about 30 minutes left. So we have seen that I use one of the TRIZ tools to define that problem, the main function as well as 4 arms. And now I am going to do part 2 to tell you some examples to solve here, right? So there's 2 of them here. So one is a physical contradiction and second one is eliminate the harm. So these are the 2 things I am going to do. First thing is physical contradiction. There is a way of defining problem in TRIZ which is called a physical contradiction. I will take some examples so you understand, and then I will take the second one. Again, I will take 2, 3 examples and you understand. You have to apply a similar technique to your own PhD problem. So physical contradiction, define physical contradiction. Physical contradictions are situations where one object has contradictory opposite requirements. So let's take the example of airplane. So airplane wings must be broad during takeoff and landing. Why? Because the speed is very low. When the speed is low, I want more stability, and therefore the wings are broader. They are broad. And therefore we now go and do this, and during the cruising, once it is at a height 30,000 feet or at a high speed of 900 kilometers, then they should become narrow. Otherwise, they will unnecessarily have drag. That means more fuel will get wasted. So if you sit in an airplane, then you are sitting on the window near the wing, you will see that when it starts taxiing for takeoff, the wings are broad. Some part comes out and it becomes double the width. And as it takes up, then it becomes less and less. The part which came out goes back again. And therefore we have the part going back and the wing become very narrow. So this is done. The problem is solved in time. The software should be easy to use, but should have many complex features. So Windows is one such where even 3-year-old, 4-year-old children are able to use it very easily. But it has a problem of virus. On the other hand, the Linux is a difficult system to use, but it doesn't have virus. And therefore, these are the 2 things. So the future software should be as good as Linux for virus immunity, and it should be as good as Windows for ease of use. So this is what we have to do. So any problem we find, there are 5 solutions. This is what the TRIZ gives. These are called the 5 tricks to solve that problem. And therefore, I am going to take some examples to show you these 5 tricks to solve that problem.
Sorry, sir. After sir, PPT
Yes.
is not visible, sir. PPT is not visible.
No, I can't do anything about it. So many people are able to see it, right?
Okay.
Yes, sir. Participants who are not able to see PPT, please pin to the sir's account, Apate sir's account.
Actually, there should be a host. Host should be able to do this.
No problem.
Host should be able to do this, I think. Next time. Tomorrow's lecture, you should do that. Host should be able to do this, pinning. Okay. Anyway, I'm sorry if somebody is not able to see the PPT. You have to see the video. I hope the video will have the PPT with it. All right. So there are these 5 things. The example of the airplane wings that problem got solved in time. At the time of taking off or landing, it is broad, and during the cruising, it is narrow. The problem got solved like that. So let's take some example. So cleaning of milk bottles. So when I first time came into Bombay, 1970, got married and had a family. So milk used to come in bottles. So the bottle used to be delivered at a doorstep in the morning. Then we will decant it in our vessel and then wash it with water and then keep it for the next day pickup. So the next day delivery boy will pick it up. But we usually don't wash it thoroughly. So some creamy layer of the milk, remnant of the milk is there. So I'm sure the bottle is dirty with some creamy layer in it, right? So what we now want to do is the cleaning of the milk bottle problem, which is all these thousands of bottles, right? Hundreds of thousands of bottles go back to the dairy, and the dairy has to clean it before they fill in again. So now the dairy has this problem that the amount of detergent for removing the creamy layer and amount of water to rinse out the detergent and the creamy layer is a problem, right? So there are 2 extremes. So this is the basic property of the physical contradiction, that some parameter has got 2 extremes, one low and one high. So at one low, that means the amount of detergent required to clean and amount of water required to rinse is less. If it is true, it is like an hypothesis. If it is an hypothesis that if I can use less detergent and less water, it will be good. Then it is economical and fast. But truthfully, amount of detergent and water should be more so that I get better cleaning. So this we call A good, one extreme, better cleaning, other extreme, economical and fast. But it is a variable, right? I can use only one value, right? Amount of detergent I have to fix, amount of water I have to fix. Is the production environment, is the factory. So what we do is we just put a ellipse or circle around it, say that I have selected this less. It is like the thumb like this, and I hold it like this. So I am already there. I have selected this, so I am going to use less water and less detergent. But then it will lead to poor cleaning, right? Because I am not using enough detergent or enough water, maybe. So what we have to do is, while holding this less detergent and less water, I have to find some trick by which I will improve the cleaning, right? I have to achieve this goal with less detergent and less water. So what are some tricks? So the 5 tricks are here, right? I'm just going to give you the 5 tricks. So these are the 5 tricks. So the 5 tricks are here. So I should do something in time. I should do something in space. I should do something whole and part. I should do something with super system and subsystem. And I should do something in condition. Now, what I am going to do is, I am going to tell you the solution, and then I will see whether we have used these 5 tricks or not. So my solution is very simple. So this is the bottle. First thing we do is we actually bring it inverted, facing down. In this bottle, I have to now clean something which is there, that creamy layer here. So some creamy layer is here, I have to now clean it. So what I will do, this bottle will come for the detergent section. Then it will move to the next section where there is a water spray, and the third section where there is a hot air drying. So let's see some animation. So there is a detergent spray, the first station, right? This bottle comes from the left side here. As soon as it is here, the detergent spray will start. And the whole idea is that this creamy layer of the left out milk has to be cleaned. So now I have a spray, and I have more density of spray near this point. This is less density, so I can now make a spray go like this. Secondly, I don't have to make it continuous, so I make it pulsating. So I give a spray and then stop. So then it has attacked this, and then all this is dissolved, and then it runs down like this here by the side. And then the next pulse of the spray comes. So it's a pulsating spray. Even for garden watering or watering of any farm, we normally use pulsating spray, which is more effective. The third thing I'm going to do is I'm now controlling the pulsating frequency. I'm going to do pulsating frequency such that it matches with the resonant frequency of this bottle. See, every 3D object has got a natural frequency of vibration. The mechanical students will understand that. We can go to a software and easily find the natural frequency of vibration. So we now pulsate this spray at that frequency. So bottle itself will vibrate because the frequency matches with the bottle state. The advantage of that is any particle matters are there, they also will become shaken. So instead of we doing it with hand, like we doing this with hand, a bottle like this, doing and shaking with hand is not required. The pulsating frequency itself does it. Pulsating frequency itself does it. And therefore it gets cleaning better. So now it goes to this bottle moves here, and now I have the water rinse, the same idea, pulsating at the same frequency which is matching with the resonant frequency. So the cleaning becomes, the rinsing becomes better. Then I go and then go to the third step, the bottle moves to the next station, and I blow hot air, and therefore all this is done within seconds. Each bottle is cleaned within seconds, and the amount of detergent and water rinse required is about 1/3 of what is otherwise required if we try to clean bottle in this way, and then decanting and then rinsing and decanting and hot air and decanting like that. So all this process is also simplified. So the tricks we used are now can be verified. All this process, I go back. So question is, I want to put a tick. Did I do anything in time? Yes, I did something here. I did something in time. So did I do anything in time? Yes. Did I do anything in space? Space means which part of the bottle was focused. The focus was this bottom part where there was a creamy layer. Did I do as a whole and part? As a whole, we don't worry about cleaning the rest of the bottle, which anyway gets cleaned. We only worry about this part. This part in space is this bottom of the bottle. Did we use super system, something outside the bottle or something about the bottle? So we did use outside the bottle. All the spray were outside. Sprays were outside. Hot air was outside. So we take that. And what was the condition? We applied the condition of natural frequency of this bottle, and the pulsating frequency was matched to that. So now, you believe me, the trick says that if we do this, and all 5 tricks we use in my solution, then it is a world-class solution. Nobody can do anything better. So I am telling you that this method of cleaning bottle is universally good. Nothing much improvement can be done. If we only have 3 ticks here, then somebody immediately after you will make the 4th tick, and then he will have a better solution. So PhD students, please, when you identify a problem and solve it with this method, you want to attempt all 5. Your solution must contain all 5 solutions. So condition also should be invented. You have to find a condition so that all 5 ticks are there. So once all 5 ticks are there, I'm sure your paper will be accepted by the reviewer. So reviewers also understand that you have done a complete process. And therefore, the more quickly I will tell you the mosquito liquid repellent, which is also very popular now. Everybody is making, but the principle is the same. So that means the mosquito liquid repellent problem has also been solved, and all 5 tricks are being used. So what is the main thing about the mosquito repellent variable? Liquid temperature. That liquid medicine or the insecticide or whatever is there, that liquid temperature is important. The liquid temperature, if it is less, then it gives me a long shelf life, right? so I don't want to heat it, then it will be there for all time. But only when I want to vaporize it, that liquid, for controlling the mosquito, then I must increase that temperature, correct? So adequate vaporization has to be there. But now I say that liquid should be at low temperature, room temperature. So I must select this, right? I should select this and say that I have selected a low temperature, room temperature. By some trick, I have to achieve this high temperature. And that high temperature should be linked to adequate vaporization. The temperature should be such that the correct amount of vapors are generated. Okay. So now let's see the solution, and then I will see whether I have got all 5 ticks. So now I have put a heater, right? There is a heater coil next to this porous black rod. So porous rod allows that the liquid rises in this porous rod by capillary action, and unless I heat it, nothing will happen. But if I heat it to 55 degrees centigrade, let's say, if I push in a current to heat it to 55 degrees, thus vaporization will happen. So now this heater is an important part, and it has to be outside the bottle. And when the heater is off, no vaporization will occur. So that's the whole idea. So this is the heater, and now I have shown you the heater, which is a little away from that, right? Only the 2/3 of the heater is on the rod and 1/3 is outside. So that means the temperature generated here by a constant current is say 55 degrees. If I bring this down, then it will become 60 degrees, correct? So that means if I have to do something in time, that I have to increase the vaporization because there are too many mosquitoes in a particular season, then I have to simply bring this heater down so that it covers more part of this porous rod, and then the temperature itself will go up, and then more vaporization will occur. And that's the way it is. So now, am I doing anything in time? Yes. I am moving the heater up and down one way, or I am increasing the current in the heater to raise the temperature for the cases where I need more vaporization. Where I am doing the heating? In space. I have identified the part of this rod, upper part of this rod, where I should heat. As a whole, the whole thing is at room temperature, only the part is hot. And then super system, yes, I am heating from outside, right? The current is being flown in that machine. And what is the subsystem? The subsystem is the porous rod and all that principle, how the liquid rises and gets vaporized. And what is the condition? The condition is that I am controlling this temperature 55 degrees for normal thing and 60 degrees for the additional thing. And we can have now see one of the gadgets. One of the gadgets you will see that there is a slider. So you can slide it. So either the sliding will move this heater up and down, or the slider will increase the current in the coil. So both ways are possible. So now I have proved to you that this also, all 5 ticks are there. So nothing much can be improved. This is a perfect system already. And therefore, it is a great solution. And therefore, everybody is now adopting it. Correct? So this is the way you have to also do with your PhD work. You have to see how many good ideas that you can apply and make all 5 ideas to work. Then you get a great solution. So now I go to the second method. This is called eliminating the harmful effects. So now we have selected as our hypothesis the 4 harms, right? The 4 harms have been identified. So we have the one good thing is the main function has to be improved and the 4 harms have to be reduced, or what we call eliminate the 4 harms. And therefore, this also is a very, very important tool for doing a quick, effective work in your PhD. This is called substance field model, and the substance field model short form is S field model, substance field, and the definition is here. I will read with you. Altshuler, the founder of this method, in 1946-47, found that every complex system function can be broken into simpler manageable subfunction till finally it reduces to a function which can be realized by 2 substances, tool and object, and one energy acting between them. This function that cannot be subdivided further is called the subfield or S-field model. So I stick to this nomenclature of S-field model. So it's a graphical model. So it's like that. So the energy is being applied, and then the hammer breaks rock, and that is the good part. The black arrow, full black arrow, is the complete good function, and the red wiggle is the harmful effect. So when you break the rock, some small chips can fly, and then it can also give me harmful effect on my eyes, right? So question is, how do you now avoid the harmful effect? So breaking the rock also is the main function which I have to improve. So in one stroke, it should break into 2 pieces or 3 pieces and so on. But harm has to be avoided. You know? The chip should not fly and hurt me on my face, eyes, etc. So very simple solution. The problem diagram is this. The harmful action or harmful effect is written here. And the next diagram has the solution in it. So use a net around the rock or protect human with a shield. Nowadays we have got a COVID plastic shield, you know, people are using. So you have to use a shield around your face so that it will not bother you at all. Correct? So that's the way it is. So this first diagram is a problem diagram before solving problem. Sorry. And the second diagram is a after you have solved the problem. So are the chips flying still? Yes. But the effect of the harm is now avoided. Isolate or absorb the harmful effect. So problem is harm need not be eliminated, but the effect of the harm should be eliminated. So this diagram is a very good picture, and therefore very, very easy to apply this method by 3 tricks. Eliminate the root cause, eliminate the action itself. So don't use hammer directly, use a chisel. You use a chisel so that this particles will not come to you. The direction of the chisel, the particles will flow in the other direction. Or eliminate the effect of the under direction. So protect yourself with a face mask. So this is easily done. You know, when welding, when we do some electric welding or gas welding, we also wear a protective thing which has got a dark glass, right, to avoid the ultraviolet glare of the welding point. So this is all protecting yourself. That means the effect of the harm has to be removed. The harm exists. So the 2 diagrams should be like this. So whenever you have these 4 harms, then we say this harm, welding. So the welding tool welds with a filler material, but the harm is that I get micro cracks. Then I should say how to avoid micro cracks. So I should have an idea of doing something with another material or process to isolate or avoid this particular harm, which is called micro cracks or voids or burr or warping, whatever it is. So we have to find one verb which will reduce the effect of that harm. And the effect of all these harms are usually on the main welding process itself. So Altshuler has given 4 methods. He says in this diagram, modify the tool. You can modify tool to actually achieve this, or modify object to achieve it, or put something between the tool and object, like use a chisel instead of directly hammering on the rock, or introduce a new substance, S3, with some energy. So like chisel, I use the chisel so that avoids the chips will fly away from me. So the chips are flying, but they are not flying towards me. They are flying away from me. So a very simple way of reducing these 4 harms which I have listed one by one, and you have to draw such a diagram for each of these 4 harms, and this, whatever is written here, is your thinking that how to reduce the effect of this harm and avoid it reducing the tensile strength. That's the whole idea, right? And therefore, while the harm can exist, its effect on the tensile strength should be avoided. So you can say micro cracks as long as they are smaller than 5 micron length, then I am okay. Or if they become nano cracks, then I am okay. Tensile strength is not affected, and so on. So Altschuler gave another good solution. He has this factory of making steel balls, and the steel balls are used for ball bearings as well as ball mills for grinding, etc. Mechanical people will know. So steel ball factory has got a final production which has to be packed in the cartons. So the balls are coming at a given speed. So it has to be bent at right angles. So the boxes are here. So they arrive with a kinetic energy and then hit this elbow. So this is an elbow or knee. It looks like a knee. So this is also called a elbow joint. So elbow joint is put here between these two pipes. So the elbow joint is here, and this elbow gets eroded. I have shown this by reducing, continuous reduction of this thickness of this metal elbow. And finally, it may actually make a hole and all these balls will fall out. And then we have to stop production, which we want to avoid. So the whole idea is that these balls are coming, the balls wear out the elbow here, correct? Balls wear out the elbow, and then pipe has to be refitted with new elbow very often. And elbow cannot be avoided as we need a right angle, and this too often. See, if things are required too often, then that's a problem, right? The problem is very often is. So Altschuler found a good solution by drawing the diagram. He drew this diagram that balls are coming with kinetic energy, they bend at the elbow and then they erode the elbow. So this is the first diagram. The second diagram is, it is still likely to erode, but it should not erode the elbow. Now balls should be there. So some balls which are here, modify the balls, modify this tool. The balls are here, and I have to use a magnetic field to attach the balls at the elbow. I have shown you in this picture. So we put a strong magnet, and then these 4 balls will get attached here. So when the new balls are coming, they are actually hitting the balls. They are not hitting the metal of the elbow joint. And then this will continue. So now I have protected elbow by the balls themselves. But then you will say that the balls will get eroded finally. So what we do is you put an electromagnet and then disconnect the electricity, and then momentarily disconnect. These 4 balls will fall down, and then again redo the magnet, energize the magnet, then new balls will get stuck here. So the balls remain only for a second, and then these balls will also fall down. So there is not much erosion on these balls either. So the size and shape and the surface of the balls, these 4 balls also remain good, and therefore all this process is now with a magnetic field here, is that the elbow will never actually get eroded at all, and therefore this is a perfect solution. This is done by Altschuler himself. This is one of the very old case studies. The magnet attracts and holds a few steel balls at the elbow. The balls collide on these stuck balls. The elbow does not get eroded. The magnet can be periodically release the stuck balls, and thus new balls will get stuck, and this process will continue, and the problem is solved. The last example, the function of a wiper. I'm just going to show you 2 diagrams just to show you that it is so easy to do. The main function of the wiper is to remove rainwater to improve driver's vision, 1, and remove oil and dirt particles from the glass, right? It is called a windshield. The glass windshield is in front of the driver. The harms are, it makes irritating noise, it scratches glass and leaves rubber marks on the glass in summer. You know that rubber melts on the glass and leaves very dirty black marks. So how do you reduce the irritating noise and the scratching of the glass? So we now make diagrams. Okay. More important gets stolen, but we will not consider that today. So wiper cleans windshield, the glass, but it simultaneously make noise, and then there is a screechy noise, and we get irritated. So we have to do something so that the noise is not there. So what do? We actually spray a soap solution while cleaning, and then it makes less noise because the soap has got a smaller constant of the is a soapy solution, or what you call the soapiness will reduce the noise because it will move easily over it. So this we know that once we add a soap solution, the noise will reduce. So whenever we actually use for cleaning, wiper cleans glass, then we actually use soap solution. The second one is scratching. So suppose a dust particle on the glass, then the dust particles, they may be, sand or something like that, strong, hard material. Then they get stuck in the wiper blade, the rubber blade, and then the rubber blade will give scratches on the glass. So what do? We modify the wiper, the soft rubber, the rubber part of the wiper, and make it sufficiently soft so that it will never give the pressure to cause scratching of the glasses. So particles are there, they also get rubbed on the glass, but the pressure exerted by this rubber is now controlled so that it never gives the scratch. And therefore this solution comes like that. So simple. First give the problem, find a solution. So soap is a good solution. Then this scratching is a problem, and then give the solution. So like this, there is a systematic way of eliminating these harms. So the same way, the 4 harms, systematically first say there are too many micro cracks, do something to reduce it. There are too many voids, then do something to reduce it. Then too much of burr or excess of weld material, do something to reduce it. And the last one is the warping. Do something to reduce warping. Right? While welding, you hold it in a jig so that the warping is minimized or something. Whatever is to be done, you do that so that we reduce all of the harms. And therefore, this is a very good solution. So TRIZ apparently enhances your creativity by getting ideas from these TRIZ tools. So one is by resolving contradictions or conflicts, which I told you in the first one, and by eliminating the harmful effect. The harm is still there, but the effect is gone. Like particles are still there, but there are no more scratches. The wiper moves on the glass, but with the soap solution, it no more gives irritating sound like that. And therefore, the TRIZ tools, there are 6 of them. I have given you only 2 of these. The 6 tools can actually help you solve the problem. The right problem is, we already have got the hypothesis that the main function improvement and 4 harms reduction is our goal. And therefore, once that hypothesis is fixed, our literature survey produces a research table and a brick wall model. And then we now put our results in that research table, and wherever we find our results are improved a lot with respect to the world's result, then we are ready to publish it. Even if they are comparable or slightly better, then we can publish it in a good journal or an international conference. So this is the way. We now have taken 2 parts. The first one is the research methodology, where we define the hypothesis. Then we use the IFR tool from the TRIZ to define the right problem, the main function and 4 harms. And then we solve this in part 2 by using 2 of the tools out of the 6 tools. There are 4 other tools also in addition. And then we can actually use these tools to quickly get good results. And if they become better in that table than the already world's best result so far, then we are ready to publish. So this is all I have to tell you. Thank you. I will of course take questions if there is any time. Organizers have to say that, because with inauguration, I think we started exactly 2 hours ago. But this is there on my notes. I will give the PDF. So this number, the participants can address me with their questions later. Only text messages, no calls or like that. And then I will try to answer them. Thank you very much. Stop the screen sharing. Organizers, is there a time for a few questions?
Yes, sir. If anyone having question, then they can ask.
Hello.
Yeah.
Sir, my name is Dr. Kiran Kakre. I'm from Mumbai University.
Okay.
My question is not related to particular core research topic, but about the PhD. If one person done a PhD in one specialization, that person can do a second PhD in another specialization, or it is better to go for a postdoc?
No, I think just continuously remaining a student is not a great idea. So I think a second PhD is not required. For example, the PhD topic I had was in electronics, and now I am guiding students in non-electronic and other subjects also. So there is no need. So there is no such thing that my PhD topic is my expertise. My expertise can grow in other subjects also, right? The PhD is just a step. It's a step in the direction of continuing research. You ask any senior guide, he is guiding students in topics which are not connected to his PhD topic, correct? No? So it is possible.
Yes, sir. So only the question is that rather than getting the PhD, can that person can do the research in another stream?
Yeah, sure. You should. I think every 15 years you should change your research topic. Otherwise, it will become boring.
Yes, sir.
And now you give your students some different topics. No, that is the way you do it. How do I do it? I give a slightly different topic to my PhD student, then I also learn with them. That's the best.
Because sir, 5 years before or 10 years before, there is an fashion of specialization. Fashion in the sense the requirement of the businesses or market is specialization. But now, after post-COVID, most of the institution or the business industries are looking for the interdisciplinary people.
See, you as a PhD person, you know how to do good research. That's the important thing. Exactly what topic you did your PhD is not important. So, some company will take you as an example in a job profile which is not matching with your PhD subject. It's okay. It's fine.
Thank you, sir.
So you can actually improve your CV by having your PhD students do work on different topics. So you also get expertise. So I think my lecture was good for PhD scholars themselves, but it is also good for the young, fresh PhD guides. The PhD guide also has to follow the research methodology with the student, so that both are working in synchronized. And if you follow that methodology, you don't have to tell the PhD student every day what he has to do. Okay, you tell him that till you find the main function and 4 harms, you keep doing it, find all the gaps in the literature, and then we'll make a hypothesis that this is what you are going to do and submit your case for registration for PhD. That's the way it should be. So I think it is useful to the guides also, my lecture, hopefully.
Yes, sir. Thank you, sir.
All right.
Okay, sir. We have one question in chat box also. Tool and skill, which is better in research?
No. Since you have picked up a topic, okay, in that topic, if it is an engineering topic, then whatever prototype you make, you have to test it, right? So to make the prototype, the tools are required, and the skills are to be there for measuring and so on. So this is what I meant by tool and skill. The processes by which you make the prototype and the process by which you make measurements on it. This is the important aspect of my PhD hypothesis, right? Both are required.
Yes, sir. Thank you, sir.
Both are required. I think there's only one question in
Yes,
this.
sir.
So I will take any questions later on my.
Good afternoon, sir.
Yes.
I am Dr. Kolgiri Somnath.
Okay.
Sir, may I? This is the nice sessions research methodology.
Okay.
So I want to know some of the bias regarding bias to formulate the research problem during the formulate the research problem. What are the effects of the bias on formulating the research problem?
No, we have to keep a broad look at the gaps. No, whatever is the existing literature survey should be aimed at finding all the gaps in that particular topic. Then we have to pick up 3-4 of these gaps and then focus on that. So of course, once we say there is a bias in the sense that once we create an hypothesis that this is my PhD work, then bias will always be there. But we have kept it broad enough. We have got 4 harms and 1 main function improvement. And any of these improves, we'll get a good PhD. If you just focus on one of them, there is a 50% chance that after 3 years you will not get a good result. Then what? You get stuck. So my focus is that students and guides should measure 4 or 5 quantities on your sample. No, don't measure only one thing which is your focus. Always measure 4 or 5 things, everything about that prototype and the gaps in that 4 or 5 measurements. And a research table should be prepared before you even begin the work. So the research table is the first good thing that research methodology gives.
Thank you, sir.
Somnath, yeah. Are you doing PhD or you are already PhD?
Sir, I am working as associate professor in SB Patil College of Engineering.
That's okay, but are you PhD?
Yeah, sir.
So now you should use it for guiding students. Okay.
Yes, sir.
So very clearly ask every PhD student to first create the research table.
Okay.
Unless you create the research table after literature survey, you don't start working. No point.
Okay, sir.
So that is my pointer to you.
Okay.
All guides, correct.
Nice, sir. Welcome.
All right. Okay. So Vishwajit, I think we are run out of time.
Yes, sir.
We'll end the session.
Okay, sir. Good afternoon, all of you. I am very much thankful to Dr. Apate, sir, for accepting our invitation and conducting session on the topic that is defining PhD problem and getting world-class result. This topic is very much useful for students who are doing PhD and the guiding for the PhD students. I am very much thankful to our head of department, our principal Dr. Mirje sir, executive director Joshi sir, our secretary Rahul Dada Mahadik, for encouraging us for conducting such activities. I am very much thankful to all my colleague faculties to help for conducting today's FTP, and also I am very much thankful to all participants for joining the FTP. Thank you, sir. Thank you all.
Hello, sir. Shindge, sir. Only last one sentence I will tell. On behalf of our management, Apate sir has given very well presentation for the research methodology. So on behalf of our Nanasaheb, once again I will thank the Prakash Apate sir and expecting the same cooperation in future also for other FDPs. Thank you.
Sure, definitely, Professor Mirje Saab. I will be very happy to interact with you and your faculty. But I am not a mechanical engineer.
Okay, let it. No problem. Methodology is same in each and every field.
So this was a generic topic, nothing to do with any particular branch of engineering. But I will otherwise be happy to guide or advise your faculty in electronics also. Okay.
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 Thank you, sir.
Thank you, sir.
It was my pleasure to be part of this first session. I hope the tomorrow session link is the same. Then I can also join whenever I have time.
Yes.
Is the link every day different?
So share the link with you.
Okay.
Yes, sir. Different link will be there. I will share a link with you, sir.
All right, sir. Thank you very much.
Okay.
And best
Thank you,
best
sir.
luck, best wishes to all participants. So you need feedback from the participant.
The feedback link for this session we will share in WhatsApp group after the completing this session. Thank you, sir. Now I announce that session is over. Thank you, sir. Thank you all.
Thank you all. Bye.
Thank you, sir.
Thank you, sir.
Thanks to all.